I know some people.
Okay, just quickly, I'm going to do the video. Okay? So if you got a question, throw it in the middle of the video.
Okay.
Okay? But anyhow, okay, so this is what we've got, and I think this is all. And I'll summarize it anyhow. You got AX equals B. Equation's inconsistent. You want to find the X line as close as possible to B. Okay? Your strategy, find the vector in the column space that's closest to B. And that's going to be the projection of B into the column space of A. So we're going to let X tilde be that projection. Actually, no, we're going to let AX tilde be that projection. Okay? We know it comes from your original space, your domain. It's in your codomain. It's an A times something in your domain. Okay, and the something in the domain is what you want to find, because we'll precede this by a statement. If X tilde is the vector that A maps to the projection, then, well, we can write this, because this is the projection. And A is mapping it to the projection under the column space, right? Okay? Well, in that case, because of the orthogonality of the null space with the column space, which is easy enough to prove, okay? B minus AX has to be in the null space, AX tilde, okay? X tilde is your goal. We want to keep that straight. Where's that goal? Okay, so B minus AX tilde, it has to be in the null space. So here's a picture. It says the same thing. Here's your AX tilde. Okay, here's your B. AX tilde is what B projects on, and B minus X tilde is this vector, which is in the null space. This picture of what this equation is telling us. So if it's in the null space of A transpose, that means A transpose times this vector has to be 0.
Yeah.
Well, we're almost home free. Okay? And this, if we just distribute the vector multiplication, you find that negative A transpose AX equals negative A transpose B, so we can just write A transpose A X tilde, right, equals A transpose B. And this is just a system of equations. Which you solve for X tilde. Okay? Sorry to do this by an inverse, and it, you know, this matrix ain't square. You know, so anyhow, there you have it. All this is computable. You can easily find A transpose multiplied by A.
Yeah.
It's going to be a square matrix, isn't it? So this matrix is going to be invertible.
Yeah.
And then you can multiply it by this. But mine not, I won't guarantee it's invertible. I have to think that through. You expect, maybe, hope it will be. But one way or another, once you write it down with the numbers, it's clear what to do. Okay? Okay. So that's pretty cool.
Yes, it is.